Okay, today we're going to continue with our lectures about conditional statements. You'll remember last time we introduced you to if-then-else statements, which allowed you to take one of two different actions depending on whether a certain expression evaluated to true or false. Today we're going to talk to you about how you can create some more complicated kinds of expressions. You saw basically just simple comparisons like, is the user ID equal to BVZ or a score greater than equal to 90? But as you know, in real life we often have multiple conditions attached to something. So for example, we might say you can get into the engineering college if your GPA is greater than 3 or your ACT score was greater than 30. So we're going to show you how you can express multiple conditions. That'll be done using Boolean expressions. And then we're going to talk about something called switch statements, which allow you to handle conditionals where you have a lot of different cases. And the if-else construct works, but it starts to look too bulky or unwieldy. And we're also going to start with looking at a common pitfall for if then else that we didn't get to last time. And here it is. This code probably isn't doing what you intended to do. So you're thinking that it's going to increment the number of honor students with A's if the person is received a grade of A, and if they're an honor student. And you're thinking, okay, if the grade's not an A, then you're just going to see out grade less than A. And it's not going to quite output what you think it is. So let's just trace through to show what's going to happen. So we'll start out and assume that both the grade is an A and the student is an honor student. So honor student, we're assuming, is a bool right here. So the first statement is true. The grade is an A. So we execute the true, what looks like the true part, and the student is indeed an honor student. So we increment the number of honor students, and it says, what is the output on the console? Well, there's nothing because the else statement did not execute. Okay, so let's see what happens in case 2, where the grade is an A, but the student is not an honor student. Okay, well in that case again, the grade is an A, so we're going to go to the true part and look at, is the student an honor student? Well, they're not. Okay, so what you probably intend is that nothing happens in this case because it looks as though you just meant for this to be a single if. That's not the way C++ sees it. Remember, C++ is strict, and it always associates the else with the nearest unmatched if. So even though you did your indentation to make it seem that this else is associated with this if, C++ is having nothing to do with it. It says, this else is associated with this if. Therefore, since your honor student was false, it's going to print out grade less than an A, which you can see clearly false. That grade is in fact, would not print the leading double quote. So it says grade is less than an A. That's not what we want. Okay? So the way that we handle this situation to get C++ to do the grouping properly is we use curly braces. Remember I said last time, make sure if you're using a compound statement and an if-else statement is considered a compound statement, use curly braces. So now everything will operate correctly because when C++ sees that we have an A here and that this then student is false, it will say, okay, where's the else? It doesn't see it, and it's before it can see this else, it runs into the curly brace. Therefore, it knows that this if statement is terminated at the curly brace, and it outputs nothing. And in that case, we would in fact get nothing printed here. So make sure when you have your nested if statements that you use curly braces to clearly delimit where one if then else statement begins and or ends, and the next one in effect begins. Okay, so again, here's that corrected code. Okay, so moving on, we're going to spend part of this time talking about Boolean expressions. And last time you certainly saw how we would evaluate an expression. That expression, we call it a Boolean expression. A Boolean expression evaluates to either false or true. Okay, and the reason I said zero or non-zero, if you remember from last time, the language that preceded C++ was C, and it did not have a bool type, and therefore it reported false values as the integer 0 and true values as the integer 1, or in fact as any non-zero integer. However, because we're in C++, we will be talking about false and true. So we can construct Boolean expressions using the normal comparison operators, and you'll often hear us refer to them as relational operators because they relate one quantity to another. And you'll also remember from last time that there is no less than equal or greater than equal, and there's also no not equal key on your keyboard, and therefore the designers of C++ had to come up with character sequences to represent those three operators, so they came up with the less than equal to indicate less than equal, the greater than sign followed by an equal for greater than equal, and an exclamation point followed by equal, no spaces, to mean not equal. Also remember that to compare two values for equality, we have to use a double equal sign. Otherwise, C++ will think you mean to do assignment if you just use a single equal. We can also construct Boolean expressions from Boolean variables. Remember last time that here a bool evaluates to true or false. So here we have the bool variable manager, and it's either true or false, so that causes the expression manager to evaluate to either true or false. And while this isn't particularly good form, you should be aware that you can use numeric variables simply because a non-zero numeric value will evaluate to true, and a numeric value that is 0 will evaluate to false. So here, if age was 70, the expression is true. If age is 0, it's false. The next way that we can construct Boolean expressions is to combine conditions. So remember at the outset of the lecture I said that thus far we've only shown you how to do simple comparisons, but you can only impose one condition, whereas we often want to impose multiple conditions, or else something can happen if either one or if two or three alternatives is true. And the way we get that is through something called the logical operators, which you'll often hear us refer to as Boolean operators. So they allow you to combine Boolean expressions, just like plus and minus can build up things, so you can build up things with the Boolean operators. So it's often in fact called Boolean arithmetic. So there's three Boolean operations: and, or, not. So with and, which in C++ we represent with a double ampersand, the expression is true only if both sub-expressions are true. So here the whole expression is true only if temperature is greater than or equal to 70 and the temperature is less than or equal to 90. That is, it's true if the temperature is somewhere between 70 and 90. Okay, or is more permissive. So and is saying that you got to satisfy multiple conditions, or is the opposite. It's more permissive. It says it's going to be true if either sub-expression is true. So here, this is where earlier I was saying you can get, let's say you could get into the engineering college if either your GPA was greater than or equal to 3 or your ATC score was greater than or equal to 30. And the or is indicated with two vertical pipes, which shows up on your keyboard somewhere on the usually upper right-hand corner of your keyboard. And you have to type two of them. Okay? And then finally, there's not. And not simply inverts its sub-expression. So here, and it's done with a exclamation point. So what we're saying is that if the GPA is greater than or equal to 3, the outcome is false because it's inverting it. So for example, here if the GPA was 4, then we're saying, well, it's not GPA greater than or equal to 3. So in fact, it's false. Okay? So it's kind of like you are saying you can go out if it's not raining. Okay? And if it is raining, you can't go out. Usually not is pretty confusing and you try to avoid it because usually you can rearrange your expression to make a positive statement. So you probably could figure out that not GPA greater than or equal to 3 is the same as saying that your GPA is less than 3. So you could express it more directly by simply saying GPA less than 3. And in fact, the most common time to see this not operator is when you have a Boolean variable. So for example, I might have bool manager, and then it does make is often fairly easy to say if not manager. And that's kind of everyone understands in plain English. Well, if that person's not a manager, do this. So oftentimes it's helpful to think of truth tables or represent the outcomes of these different operations using truth tables. So remember they and or combine two expressions. So this column here represents the results if I combine two expressions using and. This column shows what happens if I combine two expressions using or. And you'll immediately see that and is much more restrictive. It only has one true outcome, and that is when both of its expressions are true. Whereas or is much more permissive. It has 3 true outcomes. In fact, the only time it's false is when both of its expressions are false. So if, with an or, the final outcome is true if either sub-expression is true, but with and, it's going to be true only if both sub-expressions are true. And with not, it operates on a single expression and it simply inverts the value of that expression. So false becomes true when the not operator is applied. True becomes false. Okay, so here's some simple examples of Boolean expressions. And I've assumed that we have A is 5, B is 6, and C has the value 7. So based on what we've just said, you should know that C is true because it's not 0. 0 is false because 0 is a number and 0 is considered false. A is less than B because 5 is less than 6, so this expression is true. I'm using T as an abbreviation for true F is an abbreviation for false. You can see A is not equal to B. Down here, we're asking, is A not equal to 6? Well, in fact, that's true. A is not equal to 6, so that's a true statement. C is greater than or equal to 7 because it's equal to 7. If we add A and B, we get 11, and 11 is greater than C. Finally, if we look at a not operation, the easiest thing to do is often just start with the expression. So is A less than B? Yes, A is less than B, so that's true, but not inverts it, making the outcome of the expression false. Here's some more examples where we're now combining expressions using or and. So again, here's the values for A, B, and C. And we start out with an or, so we say, is C not equal to 7? Well, that's false because C in fact is equal to 7. Or is A equal to 5? Well, A is equal to 5, that's true. So the combining them gives us a value of true because with an or, it's true if either sub-expression is true. Okay, this statement right here is the same as the previous one, except that now we're combining the two sub-expressions using and. So false, if it's enough to make it false if either sub-expression is false, and since C is not equal to, since C is 7, okay, this expression is false, and therefore the whole thing evaluates to false. Okay, for 3, we're asking is A less than B and B equals 6? Well, is A less than B? That's asking is 5 less than 6? That's true. Is B equal to 6? That's true as well. Since they're both true, the whole expression is true. Finally, we have this one right here. And in order to evaluate this, it turns out you have to know the precedence order for things, and has higher precedence than the or, so it's actually going to evaluate this way. So looking first, is B less than 5? No, 6 is not less than 5, so that's false. Now we go to the other side of the expression, to the other sub-expression. Is C greater than or equal 7? Why, yes, that's true. Is A less than or equal 5? That's also true because A is 5. So true and true gives us true. And now we combine, is it F or true? And because it's an or, the outcome of the whole statement is true. Now, C++ does something called short-circuit evaluation. And that means that if the first arm of, or the first sub-expression determines the outcome, we don't even evaluate the second arm. So you'll often hear me refer to the sub-expressions as arms. So in the first case, here's some values. You can see that ACT score is greater than 30 because 35 is greater than 30. That means this is T, and we know that since this is an or, the whole expression is true. We don't even care what the second sub-expression is, and so C++ is lazy and doesn't evaluate the second sub-expression. And that has some rather nice consequences. For example, we might not want to do our miles per gallon calculation if gallons consumed is equal to 0. So what we can do is first ask, is gallons consumed not equal to 0? And only if gallons consumed is not equal to 0 do we want to divide miles driven by gallons consumed. So let's say in this case that gallons consumed is 0. Well, what happens is this statement is false. Okay, gallons consumed is 0, and it's therefore is not equal to 0. because that makes our and statement false, because either sub-expression being false makes it false. There's no reason to even evaluate this second expression. We know it's false. And by not evaluating the second sub-expression, we save ourselves a floating point exception, because if I tried to divide 500 by 0, I would get a floating point exception. So this lazy evaluation can be very handy, and you'll hear me refer to it as either lazy evaluation or short circuit evaluation. Okay, the precedence rules for evaluating operators is that the comparison operators have the highest priority, and the inequality operators have higher priority than the equality operators. That's what these first two things right here say, is the inequality operators have top priority, then the equality operators, then and or has the lowest precedence. So for example, if this is our expression right here, then we would know that the inequality operators have the highest precedence, so they're going to get evaluated first. Then the and has the next highest precedence and gets evaluated before the or. If in doubt, use parentheses. Those will always get the meaning across very clearly. But you should know the precedence rules. They make good exam questions. Okay, we've already talked about this pitfall of using two, that you have to use two equal signs in an equality check. The second thing, or third thing actually, we're going to talk about now is switch statements. So sometimes we're going to find that we have a very long set of cases. Here's an example of a long if-then-else that can be somewhat hard to read, where depending on the month, which is between 1 and 12, we're going to print out the name of the season, winter, spring, summer, and autumn. Or if they don't enter a number between 1 and 12, then we're going to tell them they need to enter an integer between 1 and 12. This can be a little bit hard to read. At least some people would say this is somewhat tedious and hard to read. So to both make it simpler to read, and also it turns out there's some efficiencies associated with it that will be discussed if you go to CS 160. We're not really going to talk about it in this course. You might write this statement as a switch statement. And what this switch statement is saying is that we are switching on the variable month. If it's equal to either 1, 2, or 3, we will print winter, and then the break statement says basically jump to the end of this statement, which is down here. Otherwise, if month is 4, 5, or 6, we'll print spring, and again the break statement says jump to the end of it. If it's 7, 8, or 9, we'll print summer. If it's 10, 11, or 12, we'll print autumn. And then you see the default, which is what happens. It's kind of a catch-all in case none of the cases is met, is to print you need to enter an integer between 1 and 12. And you can also use switch statements. Back here, month was an integer. You can also use them with character constants as well. So here we're representing an employee code using a char, a single character, and we ask the user to input an employee code and then do so, and then we switch on the employee code. In this case, if it's a P, we print professor, and S, it's a secretary, D, it's a dean, R, it's a president, and the default is an invalid employee code. And you might wonder, well, with president starts with a P, why didn't you use a P right here? Okay. Notice that would conflict with this case and create an ambiguity. So an important rule for your cases is they have to be unique. Otherwise, C++ is going to get confused. In fact, you would get confused by reading the code. And switch statements are often used for handling menus. So for example, I might have a menu in Facebook that has 4 options. 1, 2, 3, 4 might be add friend, it's option 1. Remove friend might be the second menu item. Option 3 might be post a comment. Okay, and 4 might be edit profile. And the user actually would not see 1, 2, 3, 4. Okay, they just see this menu. But the way it might be represented internally is as an integer between 1 and 4, depending on which choice the user selected. So now I could represent this very nicely as a switch statement, case 1, 2, 3, and 4. So the syntax of a switch statement is you start with the keyword switch, and then it has to be either an integer or a char that you switch on. So typically it's a variable. It's going to be either an integer variable or a char variable. Then you have a number of labeled cases. Each starts with a case, and it has to be a single integer or character constant. Then you have some number of statements if that constant matches the expression. Finally, this break is very important. It causes the execution to jump to the end of the statement. If you forget the break statement, then we say that execution just falls right through to this. Without the break statement, we would actually just fall right through and start executing statements 2, and that would not be good. So you typically end each of your cases with a break statement. Okay? And each case statement has to be a single character or integer. You can't write, say, case 1, 2, 3. That doesn't work. You'd have to do it like I did it back here, where I cascaded them: case 1, colon, case 2, colon, case 3, colon. And then finally, you can have a catch-all default if you want. It's optional at the very end, where you execute something if none of the cases has been met. Okay, so it's good for implementing multiple choices, or what we call a multi-way branch. And you're allowed to have more than one statement. You don't have to use curly braces except when you begin and end your switch statement. But inside your cases, you don't have to have the curly braces. That's why the break in effect says, okay, it's the end of things. Okay, case constants must be unique. So that's why back here with the precedent, we could not duplicate the P because we'd already used it. And it does the same thing as multiple if-else statements. So you can see that back here we used basically 4 elses to represent the cases spring, summer, autumn, and you need an integer between 1 and 12. And the switch statement replaced that as you see here. So just quickly, if you look at these couple examples and try to find out which one is illegal, if you just take a moment to look, you would see that the problem is in the second one. Okay? And why is that? Because temperature is a double and we're only allowed to use either ints or chars. Okay? Take a moment and see if you can find the problem with this one. And you'll see that there's two cases with 1, and that violates the rule that cases must have unique values. Finally, if you look at this one, you'll notice that we're missing break statements. Okay, by missing break statements, what happens is that with the month being 1, our output is actually going to be January, February, and March, which isn't what we want. We just want it to print January. That's what the break statement does, is it forces execution to continue or to jump to the end of the switch statement. Not to the default, but to the after the switch statement.